Imagine a world where machines understand human emotions, self-driving cars navigate chaotic streets flawlessly, and AI systems predict diseases before symptoms appear. This isn't science fiction, it's our present reality. From virtual assistants to advanced robotics, artificial intelligence is transforming life as we know it. But how did we get here, and where is AI leading us? Join us for a deep dive into the past, present, and future of AI, the technology shaping humanity's destiny. Let's discuss the origin of AI. From ancient dreams to modern reality, have you ever wondered how machines learn to think? How we went from ancient myths about mechanical beings to powerful AI systems capable of writing essays, diagnosing diseases, and even driving cars. The journey of artificial intelligence didn't begin with modern computers. It started with humanity's imagination thousands of years ago. Today, we'll explore the captivating origin of AI, from myth and mechanical automata to groundbreaking algorithms and the dawn of machine learning. Stay with us as we unravel how artificial intelligence went from fantasy to reality, and what it means for our future. If we talk about ancient roots of artificial intelligence, the concept of artificial beings with human-like intelligence isn't new. Ancient civilizations dreamt of creating life through mechanical means. Greek mythology, the ancient Greeks told stories of Talos, a giant bronze automaton created by Hephaestus to protect Crete. Talos symbolized the earliest known concept of an artificial guardian, an unthinking, obedient machine with a singular purpose. Chinese legends, Chinese folklore describes mechanical birds and humanoid figures crafted by inventors like Yan Shi during the Zhou dynasty. These stories hinted at the human fascination with automating tasks and mimicking life. Islamic Golden Age, in the 9th century, inventors like the Banu Musa brothers designed mechanical devices, including a programmable flute player. Their work laid the foundation for automation. These myths and inventions planted the seeds of what we now call artificial intelligence. As centuries passed, imagination gave way to mechanical innovation. In the 17th century, Blaise Pascal and later Gottfried Wilhelm Leibniz built mechanical calculators capable of performing arithmetic. But the real leap came with Charles Babbage in the 19th century. His analytical engine, though never completed, introduced the idea of a programmable machine. Ada Lovelace, working with Babbage, envisioned how machines could manipulate symbols beyond numbers, essentially describing the foundation of modern computing. This era of mechanical marvels laid the groundwork for the next phase, digital computers. The true intellectual leap toward AI came in the 20th century. In 1936, Alan Turing published his groundbreaking paper on the concept of a universal machine, now known as the Turing machine. Turing's machine could simulate any algorithmic process, theoretically giving it the ability to solve any problem if properly programmed. He later asked a pivotal question in 1950. Can machines think? His proposal for the Turing test became a cornerstone for AI research. Meanwhile, World War II spurred advances in computing, with machines like the Colossus deciphering encrypted messages. By the war's end, computers had evolved from mechanical calculators into programmable digital systems. And the birth of AI as a field. AI was officially born in 1956 at the Dartmouth Conference. John McCarthy, Marvin Minsky, Nathan Rochester, and Claude Shannon convened to explore the possibility of machines simulating human intelligence. The conference introduced the term artificial intelligence and sparked research across the world. Early programs demonstrated surprising capabilities. The logic theorist, 1956, Alan Newell and Herbert Simon created a program that solved logic problems. ELIZA, 1966, Joseph Weizenbaum's chatbot mimicked a psychotherapist through simple pattern matching. However, these early systems were rigid, limited to specific tasks. Despite the hype, AI quickly hit its first major roadblock. By the 1970s, optimism faded. AI programs required enormous resources but delivered limited results. Systems like ELIZA could mimic conversation but lacked true understanding. Government funding was cut, and the field entered what became known as the AI winter. Yet, some researchers persisted. In the 1980s, expert systems, programs that applied knowledge to specific problems, revived interest. Banks adopted AI for loan approvals, and medicine used it for diagnostics. But these systems relied on hand-coded rules and crumbled with complexity. The 1990s saw a paradigm shift from rule-based AI to machine learning. Instead of telling machines what to do, researchers let them learn from data. This shift was inspired by neural networks, which mimic the structure of the human brain. In 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, a major milestone. By the 2010s, deep learning, fueled by big data and advanced hardware, achieved breakthroughs in image recognition, natural language processing, and robotics. Geoffrey Hinton's success with convolutional neural networks in 2012 was a turning point, propelling AI into mainstream applications. From ancient myths to modern algorithms, the journey of AI has been one of imagination, innovation, and perseverance. We've moved from mechanical automata to neural networks capable of creativity and problem-solving. But this is just the beginning. As AI continues to evolve, it raises new questions about consciousness, ethics, and human potential. See AI's evolution through decades, a journey of innovation and discovery. From mechanical calculators to self-learning algorithms, artificial intelligence has undergone a breathtaking evolution. It's a story of ambition, setbacks, and breakthroughs, of machines learning not just to calculate, but to recognize patterns, understand language, and even mimic creativity. We'll travel through time, decade by decade, to witness AI's remarkable journey, from its theoretical beginnings to its current dominance in our digital age. Stay with us as we uncover how AI evolved, adapted, and transformed our world. In the 1960s, AI shifted from theory to practical applications. Eliza, 1966, Joseph Weizenbaum created this chatbot, which simulated conversation using basic pattern matching. While Eliza fooled some into believing it understood them, it revealed how shallow AI comprehension was. SHRDLU, a program by Terry Winograd that could interact with users about a virtual blocks world, showcasing early natural language processing. Military and academic institutions invested in AI for machine translation, speech recognition, and robotics. But as enthusiasm grew, so did skepticism. AI struggled to handle real-world complexity. The 1970s were marked by disillusionment. Early AI systems relied heavily on hand-coded rules, which didn't scale well. Machines that solved simple puzzles failed in dynamic environments. Funding dried up as the US and UK governments reduced AI research budgets. This period became known as the first AI winter. Still, researchers quietly worked on knowledge-based systems that would soon make a comeback. AI roared back in the 1980s with expert systems. These programs mimicked human decision-making using if-then rules. MYCIN, an AI program that helped doctors diagnose bacterial infections. Financial institutions adopted expert systems for loan evaluations and fraud detection. Japan's fifth-generation computer systems project, FGCS, invested heavily in AI, sparking international competition. Yet, these systems were fragile. Changing a single rule could cause failures. By the late 80s, enthusiasm waned, ushering in a second AI winter. The 1990s witnessed a shift from rule-based systems to data-driven learning. Machine learning algorithms allowed computers to learn patterns without explicit programming. Key moments are: in 1997, IBM's Deep Blue defeated world chess champion Garry Kasparov, showcasing AI's potential in complex strategy. Speech recognition advanced, with programs like Dragon naturally speaking entering consumer markets. The internet boom provided vast datasets, paving the way for modern AI models. The 2000s saw AI integrate into everyday life. Google utilized machine learning for search rankings, and recommendation algorithms personalized content for users. 2006, Geoffrey Hinton reintroduced deep learning with his work on deep belief networks. 2007, Apple's iPhone revolutionized mobile technology, soon integrating virtual assistants like Siri. AI was no longer confined to labs. It was shaping how we searched, shopped, and communicated. The 2010s marked AI's golden decade. Breakthroughs in deep learning, powered by GPUs and massive datasets, fueled innovations in computer vision, language processing, and robotics. 2012, Hinton's team won the ImageNet competition using a deep convolutional neural network, dramatically improving image recognition. 2016, Google DeepMind's AlphaGo defeated Go champion Lee Sedol, an achievement previously thought impossible. AI applications like ChatGPT, Alexa, and self-driving cars went mainstream, transforming industries and daily life. AI's evolution through the decades is a testament to human curiosity and persistence. From simple calculators to self-learning algorithms, this journey continues to accelerate. But as AI grows more powerful, so does the responsibility to guide its development wisely. We should understand machine learning and deep learning. Unraveling the mystery behind smart machines. Ever wondered how Netflix knows exactly what you want to watch? Or how virtual assistants like Siri and Alexa can understand your voice? Behind these everyday wonders lie two powerful technologies: machine learning and deep learning. But what exactly are they? How do they work? And why are they shaping the future of technology? We'll break down these fascinating concepts in simple terms, explore their differences, and uncover how they're transforming industries, from healthcare to entertainment to autonomous vehicles. So, sit back, relax, and let's dive into the world of machine learning and deep learning. Machine learning, or ML, is a branch of artificial intelligence that gives computers the ability to learn from data without being explicitly programmed. Let's simplify. Traditionally, computers followed predefined rules. If you wanted a program to recognize spam emails, you'd write rules like, if the email contains, congratulations, you've won, right pointing arrow, mark it as spam. If the email contains, free money, right pointing arrow, mark it as spam. But this rule-based system is rigid. What if spammers use creative language like, congrats, claim your prize? That's where machine learning comes in. Instead of relying on hard-coded rules, ML algorithms analyze thousands of emails, find patterns, and create models that can generalize to new, unseen messages. Key steps in machine learning. 1. Data collection. Gather data like emails, images, or user interactions. 2. Training. Feed the data into an algorithm to find patterns. 3. Testing. Evaluate the model's performance on new data. 4. Deployment. Apply the model to real-world applications. Fun fact: the foundations of ML were laid as early as the 1950s when Arthur Samuel developed a program that learned to play checkers better than him. Machine learning isn't a one-size-fits-all technology. It comes in several forms, each suited to different tasks. 1. Supervised learning. The algorithm learns from labeled data. Imagine teaching a child to recognize cats by showing pictures labeled cat or not cat. Example: spam detection in emails. 2. Unsupervised learning. The algorithm finds hidden patterns without labeled data. Example: customer segmentation in marketing. 3. Reinforcement learning. The algorithm learns through trial and error, receiving rewards for good decisions. Example: training AI to play video games or operate autonomous robots. Analogy: supervised learning is like learning with a teacher, unsupervised learning is like exploring patterns without guidance, and reinforcement learning is like learning to ride a bike through trial and error. What is deep learning? Deep learning is a specialized form of machine learning that uses artificial neural networks to mimic the structure and function of the human brain. These neural networks consist of layers of interconnected nodes, like neurons. The more layers a network has, the deeper it is, hence the name deep learning. Example: if you show a deep learning model thousands of cat images, it first learns simple features like edges and shapes, then more complex patterns like ears and whiskers, until it recognizes an image as a cat without human intervention. Convolutional neural networks, CNNs, excelling in image recognition. Recurrent neural networks, RNNs, used in language processing and time series forecasting. Transformers, powering modern language models like ChatGPT. Breakthrough moment: in 2012, Geoffrey Hinton's team won the ImageNet competition with a deep CNN, slashing error rates dramatically and igniting the deep learning boom. Machine learning is like traditional cooking. You follow a recipe step by step. Deep learning is like a self-learning chef who experiments and improves with experience. Machine learning and deep learning are everywhere, even if we don't realize it. 1. Healthcare. Medical imaging uses CNNs to detect cancers early. Predictive models assist doctors in diagnosing diseases more accurately. 2. Finance. Fraud detection systems analyze patterns to catch suspicious transactions. Algorithmic trading uses ML to optimize investment strategies. 3. Autonomous vehicles. Self-driving cars use deep learning for object detection, lane recognition, and decision-making. 4. Entertainment. Streaming services like Netflix use ML to personalize recommendations. 5. Natural language processing, NLP. Chatbots, virtual assistants, and language translators all rely on deep learning models. Mind-blowing fact: OpenAI's GPT-4 has billions of parameters, enabling it to generate human-like text with remarkable accuracy. Despite their incredible progress, machine learning and deep learning face several challenges. 1. Data privacy. AI needs data, but how do we balance innovation with privacy concerns? 2. Bias and fairness. If training data is biased, AI decisions can be discriminatory. 3. Energy consumption. Training large models requires significant computational power and energy. Future trends. Explainable AI, XAI, making AI decisions more transparent. Federated learning. Training models without exposing sensitive data. AI and creativity. Deep learning models are being used to compose music, write scripts, and generate art. Machine learning and deep learning are more than just buzzwords. They're the engines powering the digital revolution. As these technologies evolve, they promise a world of smarter healthcare, safer transportation, and more personalized experiences. But with great power comes great responsibility. The future of AI isn't just about more intelligent machines, it's about using that intelligence ethically and inclusively. AI in everyday life. How artificial intelligence shapes our daily world. From the moment you wake up to the time you go to bed, artificial intelligence is quietly working behind the scenes. It helps your phone recognize your voice, curates your social media feed, suggests what to watch, and even assists with online shopping. But how exactly does AI influence our everyday lives? And how did we go from simple rule-based programs to intelligent assistants capable of real-time decision-making? Now we'll uncover the fascinating ways AI integrates into our routines, from smart homes to healthcare to entertainment. Let's dive in. Communication has been revolutionized by AI, making interactions faster, easier, and more personalized. Voice assistants, Siri, Google Assistant, and Alexa use natural language processing, NLP, to understand and respond to your commands. Chatbots and virtual assistants, ever contacted customer service online? Chances are, an AI-powered chatbot handled your query. Autocorrection and predictive text, when your phone suggests the next word or corrects your typos, machine learning algorithms are at work. Fun fact is that Google's AI-powered Smart Reply can generate personalized responses based on context and past interactions. Scrolling through social media. AI is the invisible hand guiding your experience. Content recommendation algorithms, Facebook, Instagram, TikTok, and YouTube use AI to suggest posts, videos, and reels you'll likely engage with. Facial recognition, tagging friends in photos. AI-powered facial recognition matches faces to profiles. Moderation and safety. AI helps platforms detect and remove harmful content by analyzing text, images, and videos. AI tracks user engagement to refine content recommendations. Deep learning models process massive datasets to detect patterns and anomalies. Example: TikTok's For You page uses a combination of user interactions, video information, and device settings to curate content. Ethical note: while personalized feeds are convenient, they can create echo chambers, environments where similar content is repeatedly shown, reinforcing certain views. Entertainment has become smarter and more immersive thanks to AI. Streaming services, Netflix, Spotify, and YouTube use collaborative filtering to recommend shows, movies, and songs based on your viewing or listening history. Gaming, modern video games use AI for non-player character, NPC, behavior, procedural content generation, and adaptive difficulty. Content creation, AI-generated music, art, and even entire movie scripts are becoming increasingly common. Behind the scenes truth is, AI models analyze user behavior, what you watch, skip, or rewatch, to improve recommendations. In gaming, reinforcement learning helps NPCs adapt to player strategies. Example, OpenAI's Dota 2 bot defeated professional teams by learning strategies through millions of simulated games. Our homes are getting smarter, more efficient, and more convenient, all thanks to AI. Smart assistants, devices like Amazon Echo and Google Nest control lights, thermostats, and even appliances through voice commands. Energy efficiency, smart thermostats, like Nest, use machine learning to adjust temperature settings based on patterns of usage. Home security, AI-powered cameras can recognize familiar faces and alert homeowners to unusual activity. Computer vision enables cameras to distinguish between family members, pets, and strangers. Predictive models analyze historical data to automate tasks like adjusting lighting or optimizing energy consumption. Even some refrigerators now use AI to track inventory and suggest recipes based on available ingredients. AI's impact on healthcare is transformative, with innovations enhancing diagnosis, treatment, and patient care. Medical imaging, deep learning models detect anomalies in X-rays, MRIs, and CT scans with remarkable accuracy. Virtual health assistants, chatbots provide symptom assessments and appointment scheduling. Drug discovery, AI accelerates drug research by analyzing molecular structures. CNNs, convolutional neural networks, analyze medical images. Predictive analytics help doctors forecast disease progression. Shockingly, in 2020, Google's AI detected breast cancer in mammograms more accurately than human radiologists. You can observe transportation is becoming safer and more efficient with AI-driven innovations. Autonomous vehicles, companies like Tesla use AI to navigate roads, avoid obstacles, and make real-time decisions. Traffic management, cities deploy AI systems to monitor and optimize traffic flow. Ride-sharing services, apps like Uber and Lyft rely on machine learning to estimate arrival times and match drivers with passengers. Sensor data is processed in real time by deep learning models. Computer vision helps vehicles recognize road signs, pedestrians, and other vehicles. Today's Waymo's self-driving cars have driven over 20 million miles autonomously on public roads. AI is no longer a futuristic concept, it's a present-day reality shaping the way we communicate, entertain, stay healthy, and travel. As these technologies evolve, their influence will only grow, making our lives more convenient yet raising important ethical questions about privacy, bias, and accountability. So, next time you use your phone or get a movie recommendation, remember, there's a complex AI system working behind the scenes, learning and adapting to serve you better. The cutting edge, innovations shaping our future. What does it mean to live on the cutting edge? It means standing at the forefront of discovery, where science, technology, and human ambition collide to create innovations that redefine how we live, work, and interact with the world. From artificial intelligence and quantum computing to biotechnology and renewable energy, these breakthroughs are pushing humanity beyond what once seemed impossible. In this video, we'll explore the most groundbreaking advancements shaping our future, because the cutting edge isn't just about technology, it's about the endless human drive to innovate. AI is no longer science fiction, it's the engine powering our modern world. Machine learning, AI systems like ChatGPT learn from vast amounts of text to generate human-like conversations. Deep learning, algorithms help self-driving cars navigate city streets, detect cancer in medical images, and even compose music. See how Tesla's autopilot uses neural networks to analyze real-time data from cameras and sensors, making split-second driving decisions. What's next? AI systems capable of human-level reasoning. Emotionally intelligent AI for personalized customer experiences. Autonomous drones for delivery services. The cutting edge of AI isn't just smarter algorithms, it's about machines that learn, adapt, and collaborate with humans. Classical computers work with bits, ones and zeros. But quantum computers? They use qubits, which can exist as both 1 and 0 simultaneously. This phenomenon, called superposition, allows quantum computers to process information exponentially faster than traditional systems. It matters for simulating molecules for drug discovery, optimizing supply chains for global companies, Cracking complex encryption protocols. Google's Sycamore quantum computer performed a task in 200 seconds that would take a classical supercomputer 10,000 years. The cutting edge of computing isn't just faster processors, it's a paradigm shift in how we solve the universe's most complex problems. Biotechnology has moved from treating diseases to rewriting the code of life itself. CRISPR gene editing. This tool allows scientists to edit DNA with unprecedented precision. Personalized medicine. AI-driven tools customize treatments based on a patient's genetic profile. Synthetic biology. Researchers are designing new organisms to produce medicines, fuels, and even sustainable materials. In 2020, scientists used CRISPR to successfully treat sickle cell anemia in a human patient. The cutting edge of biotech isn't just curing diseases, it's unlocking human potential at the genetic level. As climate change accelerates, renewable energy technologies are evolving to meet global demand sustainably. Solar power. Perovskite solar cells now achieve efficiency rates above 30%. Wind energy. Offshore wind farms generate massive amounts of clean electricity. Energy storage. Next-gen batteries, like solid-state and flow batteries, store power more efficiently. In 2023, researchers developed solar panels that generate electricity even at night by capturing infrared radiation. The cutting edge of energy isn't just cleaner power, it's ensuring a sustainable future for generations to come. Robotics. Machines that move and think. Robotics is evolving beyond assembly lines. Today, robots walk, talk, and even perform surgery. Humanoid robots. Companies like Boston Dynamics have developed robots capable of running, jumping, and performing complex tasks. Surgical robots. Systems like Da Vinci assist surgeons with minimally invasive procedures. Swarm robotics. Inspired by nature, these robots work collectively to complete tasks more efficiently. Mind-blowing fact. Japan's Robair robot assists elderly patients with mobility, showcasing how robotics can enhance quality of life. The cutting edge of robotics isn't about replacing humans, it's about empowering us to achieve more. The cutting edge is more than advanced technology, it's a testament to human curiosity and determination. As we continue to innovate, we must ask ourselves, how do we use these powerful tools responsibly? Quantum computing, biotechnology, renewable energy, and robotics are just the beginning. The future isn't something we passively enter, it's something we actively shape. Ethical and societal impacts of AI. Navigating the future responsibly. Artificial intelligence is transforming our world, enhancing healthcare, driving innovation, and powering industries. Yet, behind this technological marvel lies a growing web of ethical and societal concerns. Who decides how AI is used? How do we ensure fairness in automated decisions? And what happens when machines become smarter than humans? The privacy paradox. Privacy, once considered a fundamental right, is now a battleground of algorithms and data. AI thrives on information, our clicks, locations, and even conversations. Key concerns are: 1. Surveillance state. Governments use AI-driven surveillance for public safety but risk turning into digital panopticons. Example: China's social credit system monitors citizens' behaviors, influencing access to services. 2. Corporate data mining. Tech giants harvest user data to personalize experiences, but at what cost? Target's algorithm once predicted a teenager's pregnancy before her family knew. 3. Deepfakes and identity theft. AI-generated deepfakes blur the line between reality and fiction, posing threats to public trust and individual security. Ethical dilemma. How do we balance innovation with privacy? Regulatory frameworks like GDPR in Europe offer some protection, but global standards remain elusive. Algorithmic bias. The hidden discrimination AI systems learn from historical data. If that data reflects societal biases, AI can perpetuate, and even amplify, discrimination. Examples of biased behavior. Hiring algorithms. Studies revealed that some hiring tools favored male candidates over equally qualified women. Predictive policing. AI-based crime prediction tools have disproportionately targeted minority communities. Why does bias occur? Skewed training datasets. Lack of diversity among AI developers. Unintentional reinforcement of historical prejudices. Potential solutions, diverse datasets, transparent AI development practices, regular audits of algorithmic decisions. Ethical AI isn't just about fairness, it's about justice. AI-driven automation is revolutionizing industries, but it's also displacing jobs. Sectors most affected: manufacturing. Automated assembly lines have replaced thousands of manual jobs. Customer service. AI chatbots now handle millions of inquiries. Transportation. Autonomous trucks may soon outnumber human drivers. The paradox: while some jobs disappear, new ones emerge in AI development, cybersecurity, and robotics. Countries like Finland have implemented lifelong learning initiatives to prepare their workforce for an AI-driven future. When autonomous systems make mistakes, who is accountable? Real-life dilemma. In 2018, an autonomous Uber vehicle struck and killed a pedestrian. Investigators found the car detected the person but didn't classify them correctly. Should the programmer, manufacturer, or user be held responsible? How do we design fail-safe mechanisms for AI systems? Emerging solutions may be explainable AI, XAI, to understand decision-making processes. Global safety standards for autonomous systems. The responsibility lies not just with AI creators but with society as a whole. AI-generated content is blurring truth and fiction, threatening the foundations of democracy. In 2020, a deepfake of Barack Obama went viral, demonstrating how realistic fake videos can become. Political disinformation campaigns have manipulated elections worldwide. Misinformation spreads faster than factual content. Public trust in media and institutions erodes. Potential safeguards are AI tools like deepfake detection to identify manipulated content. Public education on media literacy. The cutting edge of AI-generated media requires a simultaneous commitment to truth. AI transcends borders, but ethical guidelines remain fragmented. The EU's AI Act aims to regulate high-risk applications. UNESCO advocates for global AI ethics frameworks. Ethical principles for AI. 1. Transparency. Open algorithms and data sources. 2. Fairness. Eliminate discriminatory outcomes. 3. Accountability. Clearly assign responsibility for AI decisions. 4. Privacy. Uphold data protection standards. Balancing innovation with ethical standards requires international collaboration. The future of ethical AI isn't just a technical challenge, it's a collective responsibility. AI holds immense promise, but with great power comes great responsibility. As AI systems become more sophisticated, the ethical and societal implications will only grow. It's up to researchers, policymakers, businesses, and everyday citizens to shape AI's future responsibly. Because in the end, AI reflects the values we embed in it. And the question isn't just what AI can do, but what it should do.